Okay, how do we decide which option to go with? Well, we're going to use a sequential decision tree. First, you have to build the tree. So you take your strategies that you have on the left, and you know that you have to make one decision. Squares represent decisions, circles represent states of nature. So we're going to build our decision tree. We start off with our square as our decision, and then we enter all of our strategies. Our first strategy is the do nothing strategy, and the do nothing strategy has a 0 upfront cost. Strategy 2, the oil samples. There is a $40 upfront cost for each sample for strategy 2. Strategy 3, regular oil changes. There is an upfront cost of $34.80 for each regular oil change. Strategy 4, we're going to do samples and oil changes. There is a $54.80 cost for doing oil changes and samples. Now, at the end of each one of these strategies, there will be a state of nature, like we mentioned before. Strategy 1, you are going to have a state of nature of a defect or no defect being present. Remember that our probability of having a defect is 0.08. Our probability of no defect is 0.92. And at the end of each one of these states of nature, there is a cost. If a defect is present, it's $1,600. If no defect is present, it's $0. So, since we are doing no preventative maintenance, our states of nature and our probabilities will be the same as the do nothing. But this time we're doing oil samples. So at the end of each of those states of nature, there will be another state of nature. If a defect is present, the test results come back as detecting the defect or giving you a false negative. We'll enter those probabilities, and then at the end, there is a cost. If a defect is present and it has been detected, there is a cost of $500 to fix it. If it gives you a false negative, the expenses go up to $1,600. Let's go down to the second branch of strategy number 2. No defect is actually present. You do the sample. There are 2 states of nature. You are given a false positive, or you're giving that no defect has been detected, which is accurate. Each one of these has their probabilities, and there's a cost at the end. And if you get a false positive and you investigate, the cost is $250. No defect is detected, $0 is your cost. Let's go down to strategy 3, regular oil change. There are 2 states of nature. 1, a defect is present. 2, no defect is present. They both have their respective probabilities, as mentioned before, and at the end, there's a cost. If a defect is present, it's going to cost you $1,600. If no defect is present, it's going to be $0. Now let's look at strategy 4. You're doing preventative maintenance, so your probabilities are going to be the same as strategy 3, but you're doing the sampling. So you're going to have 2 more states of nature for each branch. They're going to be the same as strategy 2 because the test results would come back the same. They have the same probability of accuracy for each state of nature. They have the same cost as in strategy 2. So what's next? How do you make the decision? All right, let's look at this. What we're going to do is we're going to calculate backwards. So we're going to start on the right side of the tree and work our way back to the left. What we're going to do is we're going to take and we're going to start off with strategy 1 and how you calculate the expected value for each branch is you take the value at the end of the branch and you multiply it times its probability. Again, the value at the end of the branch, multiply it times its probability, you add them together. So in this case, we're taking 1,600 times 0.08 plus 0 times 0.92, adding them together, and we're getting $128. Now let's see how much strategy 1 is going to cost us per vehicle. So the way we do that is we take our upfront cost and add it to our expected value at our first state of nature, and we get $128 because our upfront cost is 0. Next, let's look at strategy 2. Again, we're going to have to take our final cost at the end of each branch, multiply them times our states of nature, or our probabilities of each state of nature to get our expected value. So we're taking the 500, multiplying it times 0.07, and adding that to the $1,600 and multiplying it times the 0.3. And we're going to get $830. And we're going to work our way through the rest of this. Second branch on strategy 2, $250 times 0.2 plus 0 times 0.8. That's going to give us $50 as an expected value. So with this one, since we have states of nature coming together, we're going to have to multiply our expected values times their probabilities of happening. We're going to take the $830, multiply it times 0.08, and add that to the $50 times the probability of 0.92, and this will get an expected value of $112.40. So how much will strategy 2 cost us for each vehicle? Well, we're going to take the $112.40 and add in the $40 upfront cost for the sample. We're going to get $152.40. Strategy 3, we're going to take the $1,600 and multiply it times the 0.04. We're going to add that to the $0 times the 0.96, and we'll get $64. How much does strategy 3 cost us? Strategy 3 will be the $64 plus the upfront cost of $34.80, which totals $98.80. Strategy 4, we're going to take the top branch. We're going to multiply the $500 times the 0.7, add that to the $1,600 multiplied by 0.3. We'll get $830, just like above. Same thing for the second branch down. We're going to get the $50. Now we're going to come back to the initial state of nature for that strategy. We're going to multiply the $830 times the 0.04, and we're going to add that to the $50 times the 0.96, $81.20. How much does strategy 4 cost us? Strategy 4 will cost us the $81.20 plus $54.80, which is $136. Now again, all of these are on average. This is our average cost over time. So our next step is to make a decision. And the way you make a decision is, for this tree, you're looking down at what the cost for each strategy is going to be on average. And what we're going to do, this is a cost, we're going to pick our lowest average cost. And in this case, it's strategy 3 at $98.80.